Okay, so in the previous video we had got to the point here in estimating the VIX using the white paper, so the white paper from the SIBO volatility index for VIX, and we had got to the point where we had estimated F1, F2, T1, T2. We had started to implement this formula here for the put option at the exercise of 1,370. We had worked out some of the inputs to the estimation. I had copied that into the spreadsheet in the appendix here, and last thing I would like to do here is just to verify that the result obtained here of 0.000 that we can replicate that. Okay, so maybe I'll just make that a little bit bigger for our estimation and come down here to the relevant numbers here associated with the put option. So we have the put option, is the bid and the ask, 0.05, 0.35. The mid value between those is 0.2. Okay, so let's run the estimation. We said equal to the change in the 1370. So the change in K is the change in the strike price, okay, which is equal to 5. So that's just the change in the strike price going from one strike to the next, and then we divide it by the value of 1,370 to be squared 2, and then we multiply that, so that gets multiplied in turn EXP by the interest rate. The interest rate, if we recall, was given to us as 0.00305 for the shorter expiry times T1, and T1 we already estimated to be equal to the equal to 0.00683,486, and we need to change that to a decimal point. Okay, close off the bracket. Multiplied in turn by, well, let's just multiplied. Let's take brackets outside here. Okay, multiplied in turn by the difference of the 0.2, keeping in mind the 0.2 is, well, let's just do it directly. We have 0.5 plus the 0.35, that's 0.4 divided by 2 would be 0.2. Okay, and that's our value. So there's 7 zeros. E scientific notation, so if there's 7 we'll have 6 zeros. 1, 2, 3, 4, 5, 6, and then we have 5, 3, 2, 8. 5, 3, 2, 8. So we're getting the same value corresponding to what we have here. Now how is that read? Well, that value of 0.05328 is then given here as a contribution by strike. So we've got to repeat this for each call that's out of the money, and for each put, for each put that's out of the money and each call that's out of the money. Okay, so as the exercise goes up, the call options are out of the money. As the exercise goes down, the put options become increasingly out of the money. So we don't include all the puts and calls, it's only the out of the money options that we use, and then we estimate on the basis of this relationship, we estimate the contribution that's made to each, and then at the end we sum each of these values to get the 0.00632. So I'm going to try and replicate that now, set it up and see if I can verify that I can replicate the one of the parts of the estimation that we have left out here is we've still the estimate that 1 over t multiplied by f divided by k0 minus 1 to the power of 2. Okay, so a little bit of work left to be done here, but if we go back into this spreadsheet for a moment, we've observed that yes, it is possible to estimate the value here for each put. I'll set out this in a separate spreadsheet later, but just to identify the set of steps involved here, we implement this formula, right, for estimating the VIX. We're still not finished. Once we estimate this is just for one particular strike. We've got to consider all the relevant, we've got to include in all the gray areas. Okay, so we've got to include in all the areas in gray in terms of our estimation. Right, so that's going to become very important. We've got to include in all these gray fields, right, for our estimate. So we've got to repeat that exercise to take on board calls and puts that are out of the money. So where put options are out of the money and call options are out of the money. So we have to keep repeating that. Again, if we go back and look here, we can see that the estimate that we've just made here, right, of the 0.05328, that corresponds here, but we've got to do it for the next out of the money put and the next out of the money. So the strike price keeps going up, and we do it for each of those put options, and then subsequently we do it for call options as the strike price goes up. So we go from 1370 and then 1960 or 1965, and these are out of the money put options. As the exercise is falling, we go increasingly, as the exercise is falling, the put becomes increasingly out of the money. As the exercise is rising above this 1960, the call options are going also further out of the money. So we must replicate the estimate. So this estimate that we've done here, right, must be replicated again and again and again. Then for each of the relevant out of the money options, we must sum up this. So this term here must be summed for each of the contribution by strike. When we get this value of 0.00632, it's got to be adjusted. It doesn't, so this value that we have here, right, doesn't correspond to 0.018495 that we have. Doesn't correspond with the value that we have here. We've got to make the adjustment. So how do we get from 0.00632 to 0.018495? We have to make an adjustment here. The adjustment is, if we can bring into focus, we multiply it by t divided by t1. Okay, so let's just copy for a moment. Let's take that value of 0.00632. Okay, so I take this value and I'll copy, I'll bring into the spreadsheet, and I will paste, maybe just here, doesn't really matter, and we paste and say, how do we arrive at the 0.00632? Okay, so go back into Adobe, right? So when we're estimating ultimately our value here, how do we go from this 0.00632 to this value here? in our estimation, and we just simply multiply it by 2 and divide by T1. Okay, so we'll just put that underneath. How do we go from here to this value here? Well, we take the 0.000632052 and we multiply it, keep in mind, right? We multiply it by 2 divided by T1. Okay, so we come back into our spreadsheet here, and the value for T1, if we recall, is this value here. So I'm just going to copy that, and I'm going to come back, and so we know that T1 is equal to, so we'll paste. So I copy T1 and I paste as a value. Paste special value, and then we say equal to 0.00632. We multiply it by 2 and divide by T1. Okay, and the value that we arrive at is the 0.01849, which is the value that we have here. So the 0.01849 doesn't come out of thin air, right? That value that we obtained here is estimated using, of course, this multiplied by 2 divided by T1. And again, likewise, we must do the same for T2. Okay, so for the longer time period, we must perform the same exercise. But once that's obtained, then our next task is to subtract away 1 over T1 multiplied by F1 over K0 minus 1 squared. So let's just copy this for a moment. I'll try that again. We'll copy and just take a snap, and we bring it back to the spreadsheet, and I will come down one further time and paste, and as you will see, okay, if we set this cell here equal to 0.018494963, okay, we obtain that, and then go back to our spreadsheet. The last part of the Adobe document is estimating this section here. Well, that we've obtained here. Let's copy that. Okay, edit, copy, and we probably like to verify the result, but I'll just put it above here for a moment. And that figure of 0.00003203, that was obtained here by taking 1 over T1 and then taking F1 minus divided by 1960, that's the K0 minus 1 to be squared. So I'll just verify that in the spreadsheet, and I'll pause. Okay, so I've the second element here of the what's in square brackets multiplied by 1 over T1. I've replicated that here. We have 4 zeros, so e to the power of negative or 10 to the power of negative 5 multiplied by 3.2. So with 4 zeros, we get 3203. Okay, so we can verify that this formula here replicates this formula here. We get the same value. Take the difference between the two. So, okay, so we take the difference between the two values, and the result we get here is the same as here. Okay, the result we obtain here is the same as the result here. So that is for the shorter expiry.